So we're going to look at something that's going to help you with your Mathia. It's another way to write an equation of a line. And this one's called point slope because we're going to use the point and the slope. So we're going to write an equation parallel. So when we do that, we have the same slope. So we're going to write an equation parallel to this one, but it needs to go through this point. When we do that, we're going to use the same slope. The slope is 3/2. But instead of using y equals mx plus b, we're going to use this formula. Y minus the y point given. This is the y point. Then we put the slope, x minus the x point given. This is the x point that we're given. You're going to see that it's a little bit faster than y equals mx plus b. Another way to look at this formula is to say y minus the y input or output, let's say y point, equals the slope times x minus the x point. That's really all we're doing. So we have every point has an x and a y. Why don't we call it xy? Because the formula is going to have an x and a y in it. So let's just take a look. You'll see it's much faster. If we're going to do an equation parallel, we're going to use the same slope. So the slope will be 3/2. So we're going to say y minus the y point, minus 5, equals the slope, 3/2, remember m is slope, times x minus the x point. So the formula has a minus, but then the x point also has a minus. And in Mathia, you could leave it minus minus. It'll change it for you. If we're not on Mathia, we remember minus minus becomes plus. So you're done. So it's a little bit faster where you don't have to plug it in and solve it. Again, you might have had this cut off. Y minus the y point is equal to the slope x minus the x point. And the x and y point, we call it y1 and x1. So let's try another one. We're going to now do perpendicular. We're going to write an equation perpendicular to y equals 2/3 x minus 5. And we're going to pass through a certain point. So our formula is going to be y minus the y point is equal to the slope x minus whatever the x point is. So let's do that. Now when we have perpendicular, we're going to flip it. That's called the reciprocal, and we change the sign of the slope. So if our slope was 2/3, our new slope is going to be -3/2. We flip it and we change the sign. So let's finish. The y and the minus is there, and our y point, since we have the point -10, 4, our x1 and y1, our y point is 4. We set it equal to the slope, put our parentheses, x minus whatever the x point is. And it happens to be a minus, so we have a double negative. Mathia will take that. If we are not in Mathia, we would do y minus 4 equals -3/2 x plus 10, because a minus minus becomes plus. So you actually don't have to do the solving to find the intercept b if you use y equals mx plus b. So let's try one more. We're going to take an equation parallel to this. And passing through the point negative, or let's do a positive for x, 4, -6. So again, we're going to take x, we're going to take y minus our y point, we call it y1, and then we're going to set it equal to the slope x minus our new x point. So our new x and y point, we call it nu1, nu1. So x1 and y1. So once again, y minus our y point, so it's a -6, equals a parallel slope is the same. So we do the same slope, x minus the x point, 4. Mathia will take this. If you're not in Mathia, you can turn it into a positive. Double negatives become positive. Slope form makes it so we don't have to plug in and solve for b when we use y equals mx plus b. So it's another way to write the equation of a line.